And thanks for sticking around. So I'm Deepu Sasidharan. I'm a developer advocate at Okta. I'm a polyglot developer working with many different languages, open source, aficionado. Have done a lot of open source. So today we are going to talk about Passkeys. So how many of you have already actually tried or used Passkeys? Oh, nice. Okay. No, I'm happier when there are less people in the audience who have tried it, so that So first things first, right? Like, why do we even need to go passwordless? Why can't we just keep using passwords? It's easy, right? Like you can share your Netflix password with your family. It's easier, right? Sharing around is easier. But passwords, they're very problematic, right? Then the most important reason to go password would be the problems with social engineering, all these things that comes with it. So according to a very own report, 2023 data breach report, stolen credentials and phishing account for 65% of all data breaches. So that's a lot, right? And I don't think we have evolved, enough to use passwords properly. It's not a technology problem. It's a human problem, according to me at least. Because for passwords, it expects us people, like mere folks, to do a lot of things, like remember them, store them, secure them, not share them, not reuse them. It's literally not possible, right? And quadrillion times, people have demonstrated we are not good at any of these. We can't be trusted with any of these. So it's a human problem, right? So there are a few more problems with it. It seems like my slides are a bit more delayed there than here. It's weird. OK. So passwords are also knowledge-based. Yeah? Huh. I do have a demo at the end. I mean, this works, I know, for sure. I use it for all the time. OK, hope it stays. Sorry about that. So there are a couple of problems with password, right? So number one would be password is knowledge-based, right? So they are a hassle to remember and secure. I mean, if they are easier, they are not secure enough. And if they are very secure, which is very complex, then they are not easy to remember. Then you need to do additional things, like have a password manager, have a password for the password manager, remember that, all sort of stuff. So it's a hassle. And today, we use thousands of services, right? So there are requirement for thousands of passwords. So nobody can remember that many passwords. So you end up reusing passwords. At least people in the tech world, we use password managers and stuff. But people not in the tech world, I don't think most of them are using password managers, apart from whatever comes in the browser, right? So it's a bigger problem than what we. I mean, we might think that, hey, I'm using a password manager. It's not a big deal. But no, if you take everyone using the internet, it is a bigger deal. No, it's not just us, right? And the most important problem with password being knowledge-based is social engineering, right? People are so easy to social engineer. If you look at most of data breaches and most of these hacking incidents happening, at the root you will find that it was social engineering. Someone social engineered someone to reveal a password or some data which could lead to the password. So it's always social engineering. So that's the biggest problem. And next is phishing. Okay. I think I need to wait a few seconds. So next is phishing. So phishing websites can easily harvest passwords from even the most tech-savvy. How many of you have, entered something into a phishing website, or at least visited a phishing website without knowing? Okay, some honest people. I know more of you have done so, but another problem with passwords is remote replay, right? Them being, shared secrets, you can access an account from somewhere else, right? You don't have to be physically present to access an account or access a service. So that is also a problem. And another problem is data breaches. Because passwords are stored somewhere in a server, they can be breached. Even if they're encrypted or whatever, there are possibilities to breach them and get those passwords. And we hear a lot of incidents of data breaches and password leaks all the time. So another issue with passwords is, of course, we share, we reuse passwords. How many of you reuse your passwords? Great. I do. I can't remember more than like 3 passwords, so it's impossible. Of course, password managers help there, but yeah, not for everyone. So, I mean, if I ask my mom, and I mean, she doesn't set her own passwords. I do most of them, but if she has to, it is always going to be one password, and most probably it's going to be like my name or something like that. Very simple, one password everywhere. That's what most people do, right? Like most people not in the tech world, that's what they do. Another issue with the password is for the server side. I mean, all the other issues are kind of tied to the people using passwords, right? But there's also issues for us building services using passwords, right? Because they are shared secrets, we have to do a lot more. We have to, have more security around our stuff. We have to encrypt them. We have to have recovery flows, reset flows, and in some use cases, you have to rotate passwords. All these sort of stuff. You have to use password managers, this, that, multi-factor authentication. A lot of hassle just because they are shared secrets, right? Did you know that, like, a password reset on average costs around like $70. So there's that. So it also costs money, right? So this is where passkeys come into the picture. So passkey is a unique cryptographic key pair that allows you to sign into. Okay. I have no idea what is happening here. Okay, something weird is going on. I'm going to try again. Stay. I guess. Okay. I think went past a lot. I think I was here, right? Okay, I don't know what's happening here. Sorry, guys. Something is going on here. Okay, stay. I hope it stays. That's weird. Think I was here? Yeah, so passkey is a unique cryptographic key pair that allows you to access online services without using passwords. So it is based on asymmetric, public key cryptography, which I think most of you might know. Like it involves a public key and a private key. We'll go into that. So in my opinion, a secure passwordless future is going to be one where everyone uses passkeys. So everyone, like including general public, right, not just tech folks, using passkeys, we probably will get rid of most of these, the 65% kind of issues, right? Password breaches, social engineering, these kind of things. So how many of you signed up passkeys for like, Google or GitHub? Awesome, awesome. And did you like the experience of using it so far, like passkeys? Okay, I'm assuming you liked it, right? Okay, we'll get there. It's quite new, so there is a lot more to go. I'll come to that. So before we dive in a bit more deeper, I think it is important to understand some of the underlying technologies. First one would be, of course, public key cryptography. So asymmetric public key cryptography is based on a pair of mathematically linked keys, a private key, which is kept secret by the owner, and a public key, which can be shared publicly. So it has 2 use cases. One is encryption. So if you encrypt a message with a public key, only the private key from that pair can decrypt it. So you can use it for encryption, and also you can use it for digital signatures. So if you sign a message or whatever with a private key, right, you can verify that it is signed by a particular private key using its public key. So you can actually verify signatures, and that is how you're doing digital signatures on PDFs and all those things. It's using this. And passkeys also use this particular way. And next piece of the passkey puzzle is an authenticator, right? So an authenticator is a hardware or a software device that can generate public key pairs and store them So that's an authenticator. And this keys will be used for registration and authentication in Passkeys. And there are two types of authenticators. We have platform authenticators. So platform authenticators are built into your devices. So for example, like Touch ID, Face ID, your smartphone authenticators on Android, Windows Hello, all these things. These are platform authenticators based on your trusted platform module, or I think Apple calls it Apple Enclave or whatever. So these are in your devices. These can't be taken out of your devices. These are platform authenticators. Then there are roaming authenticators, which are removable devices. They can be used with any device where you sign in from. So YubiKeys, oops. YubiKeys are roaming authenticators. You have Google Titan keys, like many other brands of security keys. Your smartphone is also a roaming authenticator. You can use your smartphone as an authenticator. I'll show you later on. Okay. And next one to understand is FIDO. So FIDO stands for Fast Identity Online. So it's a global authentication standard based on public key cryptography. It is from an association called FIDO Alliance, which aims to solve all our password problems. So FIDO credentials are cryptographic key pairs, which can be used for authentication. And the specific spec that is used for Passkeys is called FIDO2, which comprises of two other specifications. So it has web authentication, which is, I think you probably heard of Web Authn. It's a W3C standard. And then there is something called Client to Authenticator Protocol, or CTAP. So these are the two things that makes up the FIDO2 standard, which is used for Passkeys. So let's break that down as well. So Web Authn, as I mentioned, is a W3C specification. It lets a web page use a set of JavaScript APIs to talk to authenticators, platform or roaming. That's Web Authn. So Web Authn uses credential management API in your browsers. And it consists of three main parts. So the authenticator, as we saw. Then there is something called relaying party, which is the server which needs the authentication, or where you're registering to. It's called relaying party. And that is where your public key information will be saved. And the third would be your client, which includes like your browser, which does the Web Authn calls and stuff. So that is Web Authn. And then we have the client to authenticator protocol. So this is used for communication with different authenticators over USB, NFC, or Bluetooth. And specifically, version 2 of the protocol is used for Web Authn API to talk to roaming authenticators, because for platform authenticators, it is done within the platform. So you need CTAP only for roaming authenticators. So now that we understood the technologies, we can define Passkeys a bit more. So Passkeys are discoverable passwordless FIDO credentials. That's the expanded term for Passkeys. So this is what Passkeys are originally called FIDO multi-device credentials. So that changed to discoverable passwordless credentials now. It might keep evolving, but for now, these are called discoverable FIDO credentials. So there are two types of Passkeys. The first variant is called synced Passkeys. So synced Passkeys have a better user experience, and this is going to be the one that is going to be widely adopted and used by general public. I don't think the next variety is going to be used by general public, but this might be widely adopted. And this could be widely adopted. And this is being pushed by all these companies like Apple, Google, Microsoft. They are pushing this for adoption, right? They have a better user experience because the private key is roaming. So the private key gets synced to your platforms, whatever, like for example, iCloud has what is it called? The iCloud keychain or something, right? So it gets synced there, and in the Google ecosystem, it gets synced to the Google Password Manager. So yeah, different, like you can also sync it to your Bitwarden cloud or OnePassword or whatever. So you can sync your private keys somewhere. Of course, it is end-to-end encrypted, so it's not like someone can get them and use it. And it has better usability because it is easier. You don't have to register things in multiple places. You can recover them if they are lost because it's in your cloud. They can be restored on new devices. The downside is they are slightly less secure than the next variant because of this private key being sent to your cloud. The next variant is called device-bound passkeys. So these are passkeys that does not leave your device, your authenticator. So mostly these are related to hardware authenticators like a YubiKey. So if you use YubiKey to create a passkey, it doesn't leave that device. So the private key stays there. Nobody can get that. Doesn't go to any cloud. So it is much more secure than the other variant, but it is not as convenient, because if you're using a YubiKey, you would have to use it on every service you register, every device you use, and if you want to have a recovery kind of mechanism, then you have to use multiple keys as backups. So it's slightly less convenient, and if you're using a hardware-bound or device-bound passkey, best practice is to have backups, because if you lose your primary key, you can't recover your accounts. Services might give you some sort of recovery flows, probably, if they support device-bound passkey. But yeah, they have a slightly less convenience factor. So for example, I use YubiKey because I use Linux. So Linux doesn't have any sort of platform authenticator support, even though we have TPM chips. The software is not there for passkeys. So I use YubiKeys for most of my passkeys. So they are device-bound to my YubiKey. And if I want a sync passkey, then I use my phone as the authenticator, which can do sync passkeys using something called cross-device authentication. We'll come to that. So how does the magic work? Let's go into the flow. So the user goes to a website. So you as a user, you go to a website, you start your authentication process, you click on a button for registration or whatever, right? So the relaying party, so your friend end sends a request to get a challenge from your relaying party. Relaying party replies with a randomly generated string to avoid replay attacks and stuff. So your client got the string. Then your client makes a call to credentials.create, which is the one of the Web Authn API method. Which invokes your authenticator. So depending on what kind of authenticator you have, it's either synced or device-bound. So your authenticator creates a private public key pair, right? So this private public key pair is unique for that particular relaying party's domain and the username that you're using. So they're bound to these. So you cannot use a passkey that is created for one service for another, because it is bound to the domain. So you cannot do that. And that is how phishing resistance and stuff works. We'll come to that. And if it's a sync passkey, then there is one more step of it getting synced to your cloud, iCloud Keychain or Google Password Manager or wherever, right? And this is the only difference with the device-bound passkey, that one part, like this is the only difference. Everything else is the same. So once this happens, the private key, the authenticator uses the private key to sign the challenge that was created by the relaying party in the first step. Then it creates something called an attestation object. And this attestation object has the signed challenge, a credential ID, the certificates used, and all these metadata. So then your client-side implementation can take all this information and send it to your relaying party. So your relaying party will ensure that the challenge, signed challenge matches the public key to verify, and then it can store the public key in its database, and then you're registered, right? So that's the registration flow. So once you're registered, you of course want to authenticate, right? So authentication flow is quite similar, except for a few steps. So you go to the website, you click on your login button or whatever, you send a request to your relaying party to get a challenge. Okay. I can see it here though. Okay. I can see it here, but I don't know what's happening.
May I ask a question?
Yeah, sure.
How the public key arrives to the
Relaying party? Yeah, so when the client generates so your authenticator generates the key pair, and you get the public key in the attestation object. So it's like CBOR encoded stuff in the object. Then your client-side implementation, the JavaScript code, right? It can send this to your backend. So you have to send in your front-end application, you have to send it to your backend. So that you have to do. The application developer has to do that. So it's generally that object which has the public key, something called a credential ID, a unique ID for that particular credential, the certificates and stuff used, all these things, and yeah, some other metadata. So you can send this to your backend, then get the public key, verify the challenge, and store it. So you technically only need to store the public key and the credential ID to identify. Everything else is like optional. If you want, you can store them, but not necessary. Okay, what am I supposed to do? I don't know. Yeah? I don't understand. Sorry, guys. It's sorry. Oh, those are still working, but okay, maybe yeah, you guys, some of you can move backwards and like. No, for me it's fine. Like for them. Yeah, it's fine. Okay. Thank you, folks. Yeah? Okay. Where was I? Okay, so yeah, you begin your authentication, you get a challenge from the server relaying party, then your client side will make a call for credentials.get. So earlier it was credentials.create, and now you call credentials.get. So these two are the methods of the Web Authn API. So entire Web Authn API is just these two methods. So you call credentials.get, which invokes your authenticator. So again, based on what you're using, it's either synced or device bound. So the user has to provide attestation using like touch the YubiKey or your fingerprint on your fingerprint reader for sync passkey, whatever. So you have to authenticate using biometrics or whatever. Once that is done, the authenticator will fetch the private keys associated for that particular domain which you're trying to sign into. So this is where the sync passkey would differ slightly from hardware bound. This part, especially if it is a new device. So if you're on a new device and if you're trying this authentication flow, your private key is not there, and on the first attempt, it will sync your private key from whatever cloud you have. So that's the sync passkey bit there. So the user selects the private key they want based on the username they want to use, and the private key is used by the authenticator to challenge to sign the challenge that we got. So now something called an assertion object is generated. So earlier it was called an attestation object. Now it is called assertion because they are asserting, right? So this assertion object will contain the signed challenge and the credential ID. So your client side will send this to your backend. Your relaying party or the server will verify that the challenge is signed by the private key of the public key that it holds. Right? So you take the public key, verify the challenge. If the challenge is verified, that means the user holds the private key for that public key, so you can authenticate the user. Then the user is authenticated. So that's it. So that's the authentication flow. So quite similar, but slight differences here and there. So now that we understand how Passkeys works and what they do, the question would be like, why Passkeys? Right? Why is it better than passwords? Right? So we saw all the issues with passwords, right? So Passkeys solves all of these issues, right? So like knowledge base, right? Passwords are knowledge base, but Passkeys are not. Like so. Passwords are something you know, whereas passkeys are something you have, which is much more secure, right? So they are discoverable credentials, which means the browser can fetch them and they are discovered. And sometimes you don't even need to remember usernames because the browser's autofill UI will fetch these and show you, including the username for the keys there for that particular domain. So you can just click on it, right? You don't even have to remember the usernames in many cases. The next issue is phishing, right? So passkeys are phishing resistant. In the sense, probably you already picked that up, right? Because these key pairs are tied to your username and the domain, especially the domain. So if you go to a phishing website and try to, you cannot. First of all, you go to a phishing website, your browser won't even show you any keys because the domains don't match, so you're not getting anything. And even if you somehow manage to get the private key from your authenticator, which is next to impossible, and send it to that particular site, they can't do much with it, right? Because it's not going to work because the domain is different, your username it's not going to. So the browser is not going to let you enter that into that particular field. So you have to manually fetch it and send it to them somehow, which is next to impossible getting these out of these authenticators. And next was remote attack, right? So passkeys are remote attack resistance, basically because they are something you have. So the attacker has to have a possession of the passkey, like either your YubiKey or your device where your biometrics are. So they need possession. So they cannot sit in like some other remote country and hack your accounts. And data breaches, right? Data breaches mainly happen because of storing passwords, right? So for hackers, a particular service is interesting because it has a lot of passwords stored, or credit card information, stuff like that. As for the password part, for passkeys, it's not going to work because you're only going to store public keys. And even if the hacker gets your public key, they can't do much with it because it's public information. So you can even store it unencrypted or whatever. Doesn't matter. It's still secure because it's public keys. And passkeys are not reusable and shareable. I have a star on shareable. I'll come to that. So not reusable in the sense it is unique for every username domain combination. So you cannot reuse a passkey. So every time you register to a website, a new passkey is being created. So there is no reuse at all. Generally not shareable because like you cannot get it out of your authenticators. The private keys are in your authenticators, encrypted and all that stuff. But Apple lets you airdrop a passkey, which is like out of spec. The spec doesn't have that, so it's like an Apple thing. So that's the only exception. And the maintenance part, right? Passkeys are slightly more easier for the server-side folks. Especially if you're only supporting sync passkeys, then you don't have to worry about recovery flows, reset flows, and stuff like that, because the platform takes care of all that. Syncing the passkey and all this is taken care of by the platform, so you don't have to do much. So you have that, and if you're only storing public keys, you don't have to worry as much as you worry about storing passwords and stuff. So the maintenance part becomes a bit more easier. And passkeys can also do cross-device authentication regardless of ecosystem. So even if you are on the Apple ecosystem, you can use your Android phone to authenticate, vice versa as well. So it is done using that CTAP stuff that we saw earlier. It also ensures security because you can do it only if you're nearby the device. It uses Bluetooth to make sure that your device is actually near. Both devices are actually in close proximity. The security of passkeys is much better than other options. So it's like I draw the spectrum using usability and security. So you can see, the security aspect is factual, whereas the usability is kind of personal preference. So this is my personal preference. I think passkeys are much more usable than social login and every other password combination, except for maybe like password plus your platform authenticator-based MFA. They're kind of similar, but I still put it much higher in usability because you don't have to remember a password. Of course, the most secure is device-bound passkeys, but they're not as convenient. So there's that. Doesn't mean there are no challenges. There are some challenges. I think the number one challenge would be OS browser support, because we know, right, what happens when there is a W3C standard and when browsers are involved. So of course, we are going to get inconsistent implementations, slight variations, different UIs, and all these things. So that's a challenge. I hope it goes away and everyone implements the same way, not fragmented, kind of similar UI, so that general folks have a same experience everywhere. The next issue is cloud and vendor reliance. For sync passkeys, you still have to rely on Apple, Google, or Microsoft, or your password manager, whatever you're using, to store your private keys. So you have reliance on these big companies to safeguard your private keys. Of course, there are other issues with enterprise use cases because enterprise users might want more control, which might not be possible. For example, if your organization does not allow you to use, let's say, Chrome, right? You cannot use any of the passkeys in the Google ecosystem. Similarly, if your organization does not allow iCloud on your devices, you cannot use the sync passkey feature that Apple supports, right? So there are these issues. Of course, you can still use device-bound passkeys. There are no restrictions for that because it doesn't rely on a cloud or something. It's just that particular key, physical key. So you can still use that. And for now, you still have, there is no default recovery mechanism for device-bound passkeys. For sync passkeys, yes, the platform takes care of all that. But for device-bound passkey, you still have to have some sort of recovery mechanism if you lose the keys, right? So that part is still being kind of etched out and stuff. So for now, it needs to be done. Other option would be do not support device bound, just support sync passkeys, depending on the use case. So yeah, this part is for Java developers out there. So the user experience of web authentication and passkey depends on your client-side implementations, but on the relaying party aspect can be done with Java, right? So there are two libraries you can use for this on Java. So first one is called Web Authentication. It is 100% FIDO2 compliant, supports all kind of attestation formats and validation. You can implement a relaying party server using that. So of course, support passkeys. It is used by Keycloak and Spring Security. It's also Kotlin-friendly API. The next one is called Java Web Authn Server, which is from Ubico. It's not 100% FIDO2 compliant. There are some stuff missing. It supports validation, attestation validation, and supports most of the attestation formats, but not everything. So Web Authn4j is a more complete library. So yeah, this is what I would recommend. Web Authn4j is what I would recommend if you're trying to implement passkeys on your server. I mean, if you're doing passwords on your server, right, you might as well do passkeys on your server. It's easier to implement, technically, compared to passwords. So yeah, let's see it in action. Normally, I do this as a live demo, but yeah, I'm not going to try that here. I hope this works. Okay, I already have a server running here. It's just a simple Spring Boot app which uses Auth0 as the IDP. So I actually don't do any custom stuff there. So you can see I create a Spring Boot app using Spring.io, start.spring.io. I create an Auth0 app since I use Auth0 as the IDP for Auth2, and I just take the credentials from the Auth0 app, put it into my Spring Boot app. That's it. So that's what I'm running here. You can go to this GitHub and check it out if you want. I have it there. So let's see. Okay. So I'm going to show you the cross-device authentication part. So I'm going to sign up. Where am I? Oh, okay. I just realized you don't see anything. Sorry. Okay. Okay. So yeah, I mean, since I use OAuth2, I get redirected to my IDP, and now I can sign up for an account. Let's say, okay, pick something. What did I pick? Okay, yeah, it's fine. Continue. So create a passkey. So you get few options, right? So if you have a phone connected to your Google, since I'm using Chrome, my Android phone is automatically recognized. So you can use your phone. So I have like multiple phones there. So I can use any of my phone as the authenticator. If I use that, the cross-device authentication flow will be used. Or you can use like you can register a new phone, for example. You can register a new phone using a QR code, or you can also use a YubiKey. It's the last one. If you're using YubiKey, you don't even have to select. You touch your YubiKey and it just uses it. I'm going to use the phone here. So when I do that, I'm going to continue. Yeah, so I get a notification here. So I need to click continue. So I'm going to, yeah, so I get a notification here to sign in, and it asks me to create a passkey. It ensures that both devices are nearby using Bluetooth proximity. So I'll create a passkey, use my biometrics, and done. Right? So the passkey is created now and synced to that account and done. So that's the cross-device authentication flow. And I also implemented so this is using Auth0, so I didn't actually do anything, right? So Auth0 does all the passkey stuff. I just create an Auth0 app, used it in my application, advertisement, because I work for Okta. Auth0 is part of Okta, if you haven't noticed. But I also created something from scratch. Let me. I can barely see this here. Is it visible, or should I make it? I think visible, right? Should I make it larger? I mean, I'm not coding anything. I'm just going to create run the Gradle boot command, so I don't think it matters. So this is something I built. If you look at the code for this, it's using Web Authentication for J. You can get the code here. Again, not very complex. A simple Spring Boot app. I integrated Web Authentication for J into that and configured Spring Security to use that for Passkeys and some configuration, some client-side code to call the authenticators and send the data back. That's it. So you can check it out if you're trying to implement it yourself to see how you can do that. Let's go here. So I started my server, localhost. Yeah, so very simple stuff, right? So I'm going to register. I'm going to just put something else there. So, OK. This time, I'm not going to select the phone. I'm going to touch my YubiKey. I have a YubiKey bio with fingerprint sensor. So I just touch that, and done. So now I can sign in with that. So now this is the browser's autofill UI. So if you have multiple credentials, it will list all those. So if I go back and let's say I create one more, let's say this, and touch my YubiKey again, done. So it will, okay, I need to touch my YubiKey again. So it will show you everything that it has. Yeah, so the YubiKey has all these credentials stored there. Some stuff I created for something else or whatever. So a YubiKey can hold up to 25 passkeys. It has a memory limit. So it lists everything you have there, and you can use whatever you created to kind of sign in. So this is where you don't even have to remember usernames, because the browser will fetch that from your authenticator and give it to you. So that's it. Some more resources if you want to learn more about passkeys. Yeah. Use Auth0 if you want IDP, security identity, and simple passkey implementations. And thank you. Thank you for staying back. I know it's later than you planned. And thank you very much for coming and listening to me blabber. Thank you.